Alrighty, hello, lovely year nines. Today we're looking at a new chapter today, and it's all about formulas. And this first part, chapter 6a, is looking at substitution into formulas. So formulas, you'll be well aware of what they are, and there's different formulas for different applications, and I've got some to show you here. So I've got some to do with measurement, and these are just a sample of formulas. There's a whole range of more. So, you've got some area formulas there. Over to the side here, I've got a whole range of financial formulas that people in business and accounting might use. They tend to use ratios more than anything, but still, nonetheless, they're formulas. And down here, I've got some physics formulas, and so to do with kinetic energy there, and a few other things. And so you have a range of different formulas for all different sorts of applications. And basically what we want to do is just basically substitute in the values that we know to come up with a solution. So just some definitions here. In many formulas, you'll see that there's a single pronumeral on the left-hand side of the equal sign, and we call this the subject. So in this formula here, I've got E is equal to mc squared. Well, the E there, we'd call that is the subject of the formula. So that single pronumeral by itself, that is what we refer to as the subject of the formula. Okay, so in this first example here, it's telling us to find the value of the subject when the pronumerals in the formula have the values indicated. So the first formula I've got here is F is equal to ma, and you might have seen that before. That's a physics formula. That is the force is equal to mass times acceleration. And we're told here that acceleration is 10 and mass is 3.5. There's no units indicated. That's all good. You don't really need to know that for this instance. So we just simply put it in. So force is equal to ma, and I'm pretty much just going to put in the values there. So my mass is 3.5 and my acceleration is 10, and then we'll just do that calculation there. That is equal to 35. Now all these questions are calculator based, so you don't have to do these mentally. You can use a calculator to help you out. That one was nice and easy. All right, for the second one here, I've got m is equal to a plus b over 2, and do we know what that is? That is an average formula right there. So it's the average of two values. So I'm going to put in the values that I've got. M is equal to, A is equal to 12, B is equal to 26 all over 2. And so then I'd go, all right, 12 and 26 is 38. 38 divided by 2 is 19. There we go there. Nice and easy. Just put the values in, pump out an answer. All right. Here is an example now where we let's read through it. So it says, for a car traveling in a straight line with an initial velocity of u meters per second and acceleration of a meters per second, the formula for velocity at time t seconds is given by v is equal to u plus at. So I'm going to write that down. I'm going to say here, I'm going to go, I'm going to say v is equal to u plus at. That's my formula there. So for a, we want to find u if a is 2, v is 15, t is 7. Now, we're no longer here finding the subject. So the subject of this formula is v for velocity, but we don't want to find v in any of these instances. So in tomorrow's lesson, I'll show you how to rearrange a formula. But what we can still do here is we can still substitute the values in and then rearrange to find out what we're interested in. So let's go through it here. So I'm going to say, all right, so for A, I'm going to put in the values that I know. So we're going to find u if A is equal to 2, v is 15. So I say 15, that's my v, is equal to u, that's what we want to try and find, plus at, so that's 2 times 7. So it's going to do 2, 7. Notice I don't put in any times or anything like that. I just use the brackets there. So when you got brackets, that just means you're just multiplying together. And to simplify what I've got, 15 is equal to u plus 7 twos are 14. And you take 14 from both sides and you go, all right, 1 is equal to u. All right, so u is equal to 1. That was nice and easy. All right, let's do part B here. So still going to have my v is equal to u plus at. And let's put in the value. So here we want to find out what a is. So we're told that v is 10, u is 6, and t is 3. So a times 3. So I'm just going to do, all right, well, 3a. Okay, I'm just solving a nice simple linear equation here. Take 6 from both sides. So a is equal to 4 divided by 3. Okay, so there's our first one, our second one. And I'll just come over and we'll do our third one over here. So I'm just going to write out the formula again, just so we've got it as a reference, u plus at. And this final one, we want to find t. So v is equal to 20, u is equal to 5, and a is equal to 3 plus 3t. Take 5 from both sides. Divide both sides by 3, and we get 5 is equal to t, so that means, yeah, t is equal to 5. 5 seconds there. Okay, so we still substitute in for the first step. That's what we did every time, and then we solved for the unknown. Okay, so I'll just write that over here. So your steps: 1, substitute values, and then 2, solve to find unknown. That's what we did. We substituted in the known values as the first step, and then we solved it like a simple linear equation. Now, one more problem here. And in this one, it sort of looks like a slightly harder formula that we're dealing with. And this thin lens formula, I'm not familiar with what this is. So it says 1 over f is equal to 1 over u plus 1 over v. Where it says u is the distance from the object to a lens, v is the distance from the image from the lens, and f is the focal length of the lens. So it's camera related stuff here. So find f if u is equal to 2 and v is equal to 5. All right, so let's do what we did before. So we're still going to use the same thing as what we did back up here. We're going to substitute the known values and then solve to find the unknown, except we've got a slightly harder formula here. So I'm just going to write out the formula. First up, say 1 over f, this is a, 1 over f is equal to 1 over u plus 1 over v. All right, we'll find f first up, so I'm going to just put in the values. U is 2, v is 5, is equal to a half plus a fifth. Okay, so let's do this. And then, this is our process. So multiply those together, multiply those together, multiply those together. So 1 times 5 is 5, 2 times 1 is 2, 2 5s are 10, so that is equal to 7 over 10. Add those together. Now, if I've got 1 over f, I want to do the reciprocal of that, and the reciprocal means just to flip the fraction. Now, the rule is if you flip a fraction on one side, you've got to flip the fraction on the other. So if I know that 1 over f is equal to 7 over 10, if I flip that 1 over f to now be f over 1, then that's going to be equal, I've got to flip the other fraction, 10 over 7, like so. But f over 1, if I divide anything by 1, it's just itself, so it's just going to be f is equal to 10 over 7, like so there. Okay. All right, let's go again now, and now we want to find what u is going to be. So in this second example here, write up formula, 1 over f is equal to 1 over u plus 1 over v, put in what you know. I know that f is equal to 2, and I know that v is equal to 6, so 1/6. Okay, now I'm going to rearrange the formula. I'm going to put the 6th on the other side of the equation. So I'm going to say 1 over u is equal to 1/2, take away the 6th. Okay, so let's go ahead and do this, same as what we did before. So I can say, well, 1 over u is equal to, well, 1 times 6 is 6. Take 1 times 2 is 2. 2 times 6 is 12. So that's 4 over 12, which simplifies down to a third. Okay, so I'm going to say, well, 1 over u is equal to a third. So therefore, u is just going to equal to 3. If we do the reciprocal, if we flip that fraction, we get u. If we flip that fraction, we get 3. Okay, that's that. All right, enjoy.